Well, here we have a classic Kiwi hand dryer. It has been found in public restrooms for the last probably 30 odd years. The very common design all over the place. Recently been replaced with I think they're Dyson type, what do they call them? Airblade is the word I was looking for. And there's many versions, I guess. I don't know who made it first, if Dyson did it or everyone copied it, but yeah, you can still find these in places. They're everywhere. Fairly basic in design. You hold your hand underneath, it triggers this light sensor. I guess it bounces off your hand to know that your hand is present, back into the receiver, and the fan starts up and it dries your hands. That'll be obviously the inlet, air inlet. It doesn't look like it's got a filter or anything. That would be far too much maintenance to, but yeah, doesn't work apparently. So let's have a nosy what's going on inside. To get it open, it looks like one locking bolt on the top, which has been pre-loosened, as I guess they have to get it off the wall through, you'd mount it to the wall through these holes, I'd imagine. And oh, there's a plug. Okay, so it gets wired into a main socket into there, but it does just plug in to said socket, so we can just plug it in for testing. There's our fan motor. Spinning the fan inside this great big cast solid housing there, built to last forever. If I grab the axle and spin it, it does spin. I'm not sure what direction it should spin in, but it is spinning freely, so we know that that's okay. I suppose the brushes could have worn out finally. Guess we'll find out when we get in there. And then yeah, at the bottom we have just our control PCB. What looks to be a heatsink with what I'm going to say is going to be a triac for controlling the fan, possibly. A lot of goo around here and something in the corner. Definitely had liquid trickle into it, but whether that's actually our problem, I'm not too sure. There's a nice silicon rubber gasket between the fan block and the front there. That's interesting. Still feels fairly pliable after all these years. I wonder if there's a manufactured date on here. There's an adjustment for adjusting the range, how close the hand has to be to trigger it. Don't see any manufacturing date. Numbers on the ICs say 9435 on that one, 9418. So what's that? 18th week 94 and 35th week 94 for those IC manufacture dates, possibly. Let's call it 94. So I guess let's maybe plug it in. We'll see if it's clicking when our hand gets near it, and if it should be turning the fan on or not, or if it sounds completely dead. There's also a before I get too carried away and say there's usually a heating element in there. Like, it's usually blowing hot air out, and the wires do run off up in the front there. There's two wires running off up there, so I'm going to say that yes, it would have a heating element. I have to put it like this, it doesn't want to stand up very well. It's been designed to mount against a wall, so having it on the bench, the hinges are holding it crooked and it's just going to fall off if I can get it to a point where I can actually reach that. So let's see what happens when I go plug it in. Hopefully it's not some stupid power consumption and blows the fuse. But again, it doesn't work, right? Okay. Nope. Nothing. Alright. Let's just pop a camera in front of that and see if there's any infrared coming off that sensor. No. See, I would have thought maybe some sort of infrared that you could see through a phone camera, but definitely not. So, alright, I'll pull the PCB out and see what's going on. Couple of screws, one at each end. Not a magnetic screwdriver, it seems. The top of the board looks pretty clean. So, what's on the bottom of the board? Yeah, that could be our trouble. Can I unplug? I can unplug the fan and element and power cable. Let me just make a note of where those wires go, and we will rip the terminals off. Nice and tight. Right, the next one, that one's loose. That one's loose. This one's a bit of a bothersome. Give it a little twist and see if it breaks free from all those. Oh dear. Okay. Well, that one came out. Apologies if none of the last 10 minutes weren't in focus. Stupid camera. Okay. So what just happened there is one of these pins that the wires push onto just actually came out. We can solder that back in, not a problem. But it has got rather hot. So I'm picking a high resistance has formed there. And what have we got there? Okay, oh, we have a, looks like a burned trace just there. There's a burned trace. It actually looks broken. And if we have a look elsewhere, there's our LEDs, infrared sense receive. We've got some darkening on that trace there, so that could be corrosion. It may have actually broken that trace. We'll have to scrape that back and have a look. And we've got more of the same sort of pitting that occurs on these old electronics around here, so we'll have to check that and clean it up. The triac, is that a triac? I don't know what that is. Where's it going? I'm gonna say it is a triac. It looks like it's got one of these triac driver ICs, which is sort of similar to an opto coupler, optically driven, I think they are, and that's going to there, which is pin 3. Pin 3's sounds about right for a triac. Instead of pin 1 being a gate on a MOSFET, it's pin 3, the control pin, and then we've got what looks like it, the pin 1 and 2 come back to AC mains, so that's definitely a triac. Cool. Alright, that resistor there, that looks burned as well. That's had an issue. So a couple of things to go over. Yeah, we'll check some components, shall we? Weird setting on this camera. In the menu you can choose if you want movie autofocus servo to be disabled, and if you disable it, it'll still say AF as an option, as a selection on the screen, and you can choose AF, but it just won't do anything. So I think that's a bit of an oversight. Let's check that trace and see if it is burned, if it has actually broken through or just burned off the solder mask from there to there. Okay, that's still good, it's just got super hot and burned off the solder mask, but it does look like it will break if we don't do something about it. Peeled off the board itself, so let's put a bit of wire in there. Where does it go to? It goes to bridge rectifier, little black thing there, and it goes to, that's our negative out, which goes through that resistor that was burned. So that resistor, what value is on that? I don't like the way that felt when I just pushed it aside. I think it just ripped off the solder pad. Hang on, I need to have a closer look. So this should be 680 ohms. Let's do a check on that. Are you still 680 ohms? No, you are 0. I guess we'll check that diode. It goes to that capacitor. That capacitor won't be shorted. No, it's fine. Actually, did I just totally balls that up? I may have just totally balls that up. Sorry, my meter was in the wrong mode. Ha ha. Okay. No, nothing wrong with that resistor. She's still 680 ohms. Even though it's a little black on the end. That's interesting. Sorry, I still had the meter in continuity mode, which only goes up to about 130. Rookie mistake. Okay. So at this stage, there's nothing wrong with that, even though it looks bad. Alright, let's check the bridge rectifier. So on one side we have our AC coming in, on the other side we have a positive and negative coming out. So to check a bridge rectifier, from the AC pins, our anode with reference to positive. So in diode mode there we check one AC pin to positive, and we find a dead short, which it shouldn't be. It should be a half volt diode drop. And the other AC positive, we have a dead short. And to test the negative, we need the anode to be on the positive lead on the negative, and then we go back to each of the AC pins, and that's all shorted. So the whole thing is a dead short, which is why that track got hot and burnt up, and the resistor almost followed suit. So are they just dropping the AC in to get a lower voltage on the bridge? What are those capacitors rated at? 15 volts, 25 volts, 25 volts. Okay, so we have no, that I can see yet, we have no regulation, but here's our input capacitor from bridge. Ooh, and that's a 15 volt Zener, I think. Oh, it says 15V beside that diode and 25 volt caps. Maybe that's a 15 volt Zener. Maybe it's very crude. Maybe so they're dropping mains across this resistor and this resistor to get a lower AC value to rectify it and then regulate it with a Zener instead of needing a transformer to drop it. That's an interesting way of doing it. Just lower the AC going in. So why don't we have any AC going in? Well, our bridge is dead short, so it's not going to blow the fuse if it's not a mains short though. I hope it hasn't sent the full AC through to here. Oh, actually, let's check our Zener diode. Maybe it's clamped it. Okay. If we measure our Zener diode there, that's shorted as well, which means that's going to clamp back to negative. Yeah, okay, so our Zener has been protecting. No, wait a sec. Everything's in circuit. I'm going to have to disconnect that from circuit to know for sure because it's across our bridge. Idiot. Anyone would think I'd never done electronics before. Now we can know for sure. Is our Zener good? No, our Zener's bad. Was the shorted Zener giving us a false reading on our bridge? No, the bridge is bad as well still. Okay, there we go. It's all gone downhill. That's shorted too. Cool, alright. What about further in? I wonder if the rest of the thing's going to work. Ah, here we go. Here's another Zener 6.8 volt Zener. Oh, actually, let's just check for if we have maybe a short across our capacitor there for the rest of the circuit. Nah, she's looking really good. 9K. Let's check that other cap there, and that's got a short across that cap. So that goes to where does that feed? That feeds off into the board. There's a resistor there. Resistor there, and off down to, oh, there's an IC there. That could be bad. What else is there? Just make sure there's not a resistor across that cap. No, the cap comes off the bridge though. There we go. That's our shorted bridge giving us a false reading again. So let's remove the bridge. Let's remove this diode, and let's remove the Zener. Make sure the 6 volt Zener's alright. 6 volt Zener's alright, yeah. So maybe it's confined to the primary side mostly. So I'm thinking the 15 volt Zener, maybe there was an input surge. I mean, it's entirely possible. So there was an input surge that caused the Zener to clamp, and then it went short circuit. Maybe because it was a very persistent surge that wasn't very brief. It stayed there. So the thing stayed there for long enough that the thing got really hot and ended itself. And the bridge. Is that broken? There's another little trace there. There we go. It looks a bit dark right where it enters. Yeah, that's broken. So that's why nothing's happening, and it didn't blow the fuse, because it's blowing the trace into the shorted bridge. Missed. Hopefully I can get another one of those at my local suppliers. Be good to get this job done today. Just thinking I really probably should replace that resistor, just, you know, for longevity, just because it does look a bit bad. Even though it's measuring all right, you never know what's going to happen. Bit of vibration and whatnot later. That carboned up end could disconnect itself perhaps. Wonder if the triac shorted. I've got a couple hundred of those I bought one for another repair. Well, I bought a bunch for another repair and didn't end up needing them. Having disconnected the triac, this appears to have a short across it still, even after disconnecting the little... Alright, are we disconnected? Always go from the pin to the pad once you've desoldered something, just to make sure it's not still sitting on there. It is! Ooh! Okay, we've got a shorted triac too. It's not shorted to the control pin though, but we'll need a triac, we'll need a Zener, we'll need a bridge, we'll need a diode, we'll need a big fat resistor, marked as 5 watts. Triac's definitely been replaced before, and I desoldered the control pin. You can see half the pad's missing around it. There's budget screen capture mode for you. It is a 600 BT139600, so the ratings of 16 amp 600 volt, which is cool because I have 16 amp 600 volt in a different brand. It's BT-A16. This is indeed, yeah, 600 volt 16 amp. This thing's 30 years old. Let's just do a quick check on these capacitors. I mean, if it's worth recapping them, perhaps, just to keep everything happy for the next wee while, because it is going to get used a lot. So our big one's 220 mic, and our little one is 100 mic. 260 for a 220. It could be a bit high. Well, that one's bad. That one should be 100 mic. Alright, 6 nanofarads. That's a good start. And the other one is also 5 nanofarads. So one trip to the local store and a burger for lunch later, we have a bag of bits. Now they didn't have radial capacitors, but we'll squeeze those in. It won't matter. Tons of room in there. No biggie. We've got our Zener diode. We've got 2, one for stock. It'd be funny if I had one for last time I got one. Didn't check. Anyway, can never have too many parts, huh? Diodes. 1N4004 is what the other diode was. Our 680 ohm 5 watt resistor and our bridge rectifier. And need to grab a triac. Now the awkward one out the way, we can use the heatsink. Keep things up. Oh, we've got that one over there. Nice shiny caps in place. Next up, we'll chuck our Zener in, I suppose. We've got to dismount that triac as well. See if that's enough. Perfect. Let's clean off that old white paste and put a bit of new stuff on it. Good old dollop of that there. Make sure it's looking square. Do we want to lift it up a bit? I might just lift it up a bit. A little bit more central on the clip. There we go. Now I doubt the triac shorting out would have been the initial failure. I think it was probably, if it was a power surge, it was just caught in the crossfire. If this had shorted, it has no path to draw excess current through the bridge and blow that up. So it's probably not like there's a problem with the motor or heater, for example. If that had failed and caused this to short, that's not going to have damaged that. And vice versa, damage here is not going to have caused an issue with this. I mean, unless something, whatever happened, caused it to run continuously, and the thing just got over hot from running the heater and fan for minutes or hours on end, maybe, if that's what happened. Hard to know. So what's next? We have a Zener, a bridge, a resistor. Let's take that resistor out and just solder this pin back in, and that diode. Now remember we need to put a little wire link where that trace is burned up, just to make sure that it's all good to go, reliable. We need to fix this corner as well because it's broken. And we want it to go that way around. Find after all this the fan motor's junk, or the brushes are completely gone or something. We may as well use one of the component legs for a jumper link. Recycle the parts we've got. And we need a bit for up here as well. Use the same piece almost. Scrape back. There is no conformal coating to scrape back. That entire track back to that pin has evaporated. I don't even think I saw it inside the chassis. I'm not going to be able to detach the little pin that goes on here for the other cable because it's actually welded to it, and there you go. This is exactly what's happened on the other one. Look at that, it's melted that one as well. It did actually let go for me when I pulled it off, but I just noticed that has obliterated that. So yeah, it did a great job. What I'm going to do in this instance then, that's not going to be a good connection, so I will solder the wires directly to the PCB. So we'll pull this one out as well. And we'll want to go from there to there. So is that everything? We have diode, bridge, Zener, new capacitors, triac. We do a bit of an operation test before we attach the loads. Power it up and make sure that it is sensing hand position and that the brains aren't all blowing out. Almost forgot, we need to make sure that this trace is okay where it's discolored, and if that's fine, yeah, Nothing wrong with that trace. And does it flow through to here? Yeah. So it's just cosmetic at the moment, although I would look at scraping it off and cleaning it and resealing it to make sure it lasts. We need to see if this thing's actually going to work first before we put too much more into it. Well, I thought I'd take the motor unit out, and probably a good thing that I did. Who can spot the problem already? There's the end of our heater element. The whole thing's probably done for. Oh, that's not so bad. Actually looks half decent. Got quite a high edge on one side. The other one's looks like that high edge must have snapped off. Probably. And put it back in the same way around as it was. Also had another thought, because there's no power transformer here, everything's mains potential, even on the low voltage side, so just be aware of that. Don't touch anything here. Stick it in there for neutral, and we'll stick it in there for motor phase or heater phase. There we go. We'll go like that. So here's our sensors. So we've got a gap here, and hopefully it doesn't need to be even more confined in the housing that it would normally sit in. Wait for the bang. 3, 2, 1. No bang. Well, that's a good start. Though I am measuring 105 volts, whether that's some sort of leakage or not, or it just thinks there's a hand in the way, I'm still getting 103 volts. Okay, so something's not perfect. I wonder if it killed the little drive IC. What this control IC is something called a zero crossing opto isolator triac driver, and you can see it kind of has a triac in it itself. Pin 1 and 2, we need to have a look at pin 1 and see if we get some sort of signal on that once our hand is in range. 0 volts, and if I come near it, we have still 0 volts. The problem now becomes, why is it not picking up my hand though? There's no point putting one in if it's not going to control it. Let's have a look and see if we do have our secondary power supplies going on there. So what have we got against this capacitor here? Do we have anything coming off of our bridge rectifier? No, we don't. I'm an idiot. I totally forgot to hook up this wire to the bridge. Because I was thinking I was gonna, solder the wires of the fan directly on, and then I'd attach it then. I'm pretty sure that this is gonna be a no fix, but I want to know if this board works now, even if the rest of it's 3, 2, 1. Ah, look, 236. So now it's being turned on more, but why? Get my hand near it, nothing. So now we need to go back to square one on troubleshooting the secondary. So what's our secondary voltage? On our 15 volt Xena we get 11.2. On our 6 volt Xena we get 6.9. On our control pin on the IC, pin 1, we get 1.2 with no change there. And see where it gets controlled from. Okay, there's a transistor there that's doing that. That's our control for the transistor, so that's 0.6, so that's saying transistor turn on. So control comes from either of these two ICs. I think it's pin 1 of each of those. It's the bottom left, looking at it this way. And we got 1.2 volts there, and we got 1.2 volts there. I would expect one of those or both to drop to 0 in order to turn the transistor off, in order to turn the output off. So there's some other issues definitely some other issues. Let's see if there's anything on our, this is our LED, we've got 6.3 on that side and 6.3 on that side, so it's probably not lighting up. Yeah, looking at that, there's nothing coming out of it. At this point I'm going to say it's a lost cause. I've already thrown a bunch of parts at it, and the condition of the element being broken and the explosion on the input suggests it could have sent something nasty up the line and damaged everything else. So I guess thanks for watching. Now you've also got to see what's inside one of these things. I shall remove my parts. They'll be invaluable for a future fix. And thanks for watching.